In order to understand the concept of large sample approximation for the runs test when you are expecting that your N1 or N2 is greater than 10. Now, let me tell you that some of the textbooks, they would be referring that your sample size N1 and N2, if it is greater than 20, then you would have to make use of the normal approximation for the runs test. Whereas, as if you talk about certain statisticians, they are conservative in accepting it, and they would rather state that your N1 and N2, if they are greater than or equal to 10, then even though we can employ the standard normal approximation or the large sample approximation for the runs test. So students, I'll be sharing one example where your sample sizes are slightly greater than 10, and then we would be making use of the large sample approximation to test the randomness in the data. This was a problem where a charter bus line has 48 passenger buses and 38 passenger buses, with X and Y denoting the number of miles traveled per day for the 48 passenger and 38 passenger buses respectively. The bus company is interested in testing the equality of the two distributions at 5% level of significance. The company has observed the data that is being shown to you in form of X and Y. It is a random sample of N1 equal to 10 buses who are holding 48 passengers and N2 equal to 11 buses who are holding 38 passengers. And we are required to compare the two types of charter buses who are taking the 48 passengers or 38 passengers by making use of the large sample approximation. As you know, that N1 is 10, which is not actually greater than 10, but it is equal to 10. But if we talk about N2, it is slightly greater than 10. So we would be employing the Z or the standard normal distribution for testing the randomness in the data. Now, in order to test that, students, under step number 1, as it is a two-tailed test, because we were asked to compare that two distributions are equal, so we would be comparing that cumulative function for the first type of population is identical to that of the other type of population, and under H1 we would be considering that they are not same. Step number 2, alpha, which is 0.05. Under step 3 we have the test statistic, where we have taken the Z, which is a standard normal variable, that is equal to R, the total number of runs, minus the expected value of the runs, divided by the standard deviation or the standard error of the runs. Now, expected value of R, it is to be calculated using 2n1 into n2, and then we would have to divide it with n1 plus n2, and then finally adding 1 to it. And for the variance of R, 2n1 n2 multiplied by 2n n2 minus n1 minus n2 divided by n1 plus n2, यानी दोनों ऑब्जर्वेशंस को सम करके आप स्केयर लेंगे, मल्टीप्लाई करेंगे इसको, दोनों ऑब्जर्वेशंस के सम माइनस सब्ट्रैक्ट करेंगे इसमें से 1. So in order to calculate, the ordered array is being shown. Now why have ordered that? Because we are required to calculate the runs. So students, collectively दोनों जो data sets हैं उनकी collective ordering की है smallest से largest value तक. अब यहाँ पे जो bold में values आ रही हैं वो sample 2 की values हैं, और जो unbold हैं या unhighlighted हैं that are being taken from the first sample. So if you have just arranged them from smallest to the largest collectively for both of the samples, 104 is being taken from the first sample. So students, if you just look into it, ये आपके पास first observation पहले data में से है. These 4 observations are from data 2, यानी second sample की है. तो यहाँ पे run आपके पास हो गया 1, क्या you would have 2, फिर ये first data आ गया, then you would have 3, ये second data है, यानी second sample की दोनों observations हैं. So it would be run 4, then we have consecutive values for the first sample. So run will be 5. Then we have highlighted one, 6. Then we have these two values. Run is 7. These two highlighted that are being taken from the second sample. Total number of runs are 8. And finally, we have a single value from sample number 1. यानी कि first जो आपकी observations हैं, first sample की, उसमें से ली गई है. So we would have a total of 9 runs. Now, as we have observed that there are a total of 9 runs, so using the normal approximation to the runs with n1 equal to 10 and n2 equal to 11, we have calculated expected value of r as 2 into n1 into n2 divided by sum of the two observations. Adding a 1 to it, we have got 11.476. Whereas if we talk about variance of r, it is to be calculated using this formula which is explained earlier. So plugging all the values of n1, n2, and by making use of this formula, we have calculated the variance of r as 4.9637. And now using these expected value of r and variance of r, z is to be calculated. For 9 runs, expected value of r is calculated as 11.476 and the variance of r is 4.9637, taking its positive square root and finally taking the ratio of the two of the values. I've got the value of z as being minus 1.1114. Now what I would have to do, as it was a two-sided test, so we'll have to reject our h0 at 0.05 level of significance if z modulus is greater than z alpha by 2. That means हमने critical value का absolute लेना है. So z modulus is greater than z 0.025. Now students, as you know that our 1 minus alpha was 0.95. So 1 minus alpha को अगर आप 2 से divide करते हैं, 0.95 divided by 2, that will give you 0.475. If you will make inverse use of this value, you would have to locate this value from the standard normal table which is readily available in all the statistical textbooks. अगर आप इस value को from within the body of the normal table, अगर आप इसको search करेंगे तो इसके against आपको value मिलेगी z की 1.96. By taking the absolute of this negative value, because we were required to take the absolute of the calculated value. So negative value would be converted into the positive value. Since 1.1114, it does not fall in the critical region. Therefore, our H0 will be accepted and we can conclude that the two distribution functions, they are identical.